Good day, learners. Welcome to Technical Mathematics lesson. My name is Matule Latakomu, and this lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Okay, grade 11 learners, today we are going to be talking about sectors and segment. That's what we will be talking about today. So without any waste of time, let's look at our lesson objectives. With the lesson objectives, they go as follows. Saying at the end of this lesson, learners must be able to determine the area of a sector, and you must also be able to determine the area of a segment, and you must also understand the relationship between the diameter, height of the segment, and the length of chord. So that's what we will be talking about today. And remember, all these things that I've just mentioned there, they fall under the topic of circles, angles, and angular movement. Okay, so now looking at the part of a circle. Part of the circle is the bit of a revision. We know that in a part of the circle we have what we call a sector. We must understand the shape of a sector from the center with two radius and the arc. That is our sector. And we must also understand what is an arc. An arc is just the piece of our circumference there. And we also have our segment. Remember, our segment is formed by an arc and also a chord. Correct? And we have what we call also a secant. The secant, remember, is a line that is cutting the graph in two times. And we also having a diameter. A diameter is a chord as well, but is passing through the center, and we have a chord. A chord is the line that is touching the circle two times. We also have what we call a radius from the center of the circle to the circumference, and we also have a tangent. Remember, a tangent is a line that is touching circle at one point. Correct. So now those are the part of a circle. So now moving forward, since we're speaking about the area of a sector, so remember in grade 11, like I said before, that when we read our test and exam, we are given the formula sheet. So when we are asked to determine the area of a sector, you quickly go to your formula sheet and you look for the formula that looks like this one. So area is equal to 1 over 2 r squared theta, correct? Or they can give you in terms of area it's equal to r multiplied by s all over 2, where you know that s is the arc length, which is s is equal to r multiplied by theta. Remember, s is the same as our arc length. So in our formula sheet, these formulas, the description is given in full. They are telling you that this is the area of a sector and this is the area of not the area, this is the length of a chord. So now, with a sector, we know that a sector is formed by two radiuses together with the arc. But in determining that area, you need two radius with the central angle. And we know in this case that our angle, it must always be in radians. We know that our angle, it must be in radians. If they give you angle in degrees, you must convert it to radians, of which I know that you have dealt with that one last week. Okay, so now when we're talking about the area of a segment, area of a segment of a circle, so remember a segment, we are talking about this shaded part, and for you to determine the area of a segment, you must firstly get the area of a sector, and then you minus it by the area of a triangle. So that's how you will be getting the area of a sector. So in this case, you can see that they have simplified the formula. But in normal cases, you will have area of a segment, which is 1 divided by 2r squared multiplied by theta, minus the area of a triangle. Which triangle we're talking about is that triangle there. So we're going to have 1 over 2 multiplied by a multiplied by b multiplied by the sine of theta. So in those two areas, they are given in the formula sheet. This one is the area of a triangle, and that one is the area of a sector, for you to get the area of a segment. Correct? You can see here they're also giving you that the angle must be in radians. Okay, so now let's look at activity 1 and check how do we then calculate the area of a sector. Correct? They're saying you must calculate the area of the shaded part. Remember, the shaded part there, it's your sector. The shaded part there, it's your sector. That is the area that we'll be looking for. So you can see the information that is given there is we are having the length of OA, which is 12. That is your radius. Your radius is equal to 12. And we're also given the angle there, but the angle is in degrees. The first thing that you do, you are going to convert your angle, which is theta. Your angle is in degrees. And how we convert the angle from degrees to radians, you will multiply by pi all over 180. So if you take your calculator and you're saying 60 multiplied by pi all over 180, you will see that you have 1 over 3 pi. So 1 over 3 pi is your angle in radians. So what we do here, you will go back to your formula sheet and you rewrite the area of a sector, which is 1 over 2 multiplied by r squared multiplied by theta. That's how you get the area of a segment. I mean the area of a sector. So now you do the substitution there. It's given that your r is 12 squared, and you also have your angle now, it's given in radians, which is 1 over 3 pi. So now in that case, you will go back to your calculator again and you punch 1 over 2 into 12 squared multiplied by 1 over 3 pi. 1 over 3 pi. Then now in your calculator, you will get 24 pi. Or we can write it in decimal form as 75,40. That is your area. Remember, area, it has units squared. But in technical mathematics, we don't penalize for units. But that is how you determine the area of a sector. Moving forward now, the question, activity 1 continues. Number 2, it says you must determine the area of a major sector. Remember, we have the difference between major and minor. This area here, the small one, the one that I'm shading now, it's an area of a minor sector. It's an area of a minor sector. So for now, we have to determine the area of a bigger sector. And we can see that the central angle is an acute angle. It's less than 90 degrees. So now, for us to determine the area of a major sector, we need now the angle of the bigger sector. how to get. And then we know that that angle, if is more than 180 degrees, we call it a reflex angle. So how do we get the reflex angle there? We know that in terms of theta, looking at the circle, we are going to say its degrees is going to be 360 as a revolution, and you minus 45 degrees. So if you say 360 minus 45 degrees, you are going to get 315 degrees. But we can calculate the major sector with degrees. Remember, it's going to be 315 degrees. But when we calculate, we calculate or determine the area, we must convert that 315 into radians. So you will say, therefore, in terms of conversion, 315, you will multiply it by pi over 180 degrees. So the answer that you will be getting there, you will say 315 multiplied by pi all over 180 degrees. So in radians is 7 over 4 pi. That is the reflex angle. It means that angle now it's 7 over 4 pi. Correct. And the radius it stays the same. Remember, your radius is 12 centimeter. So you go to your formula sheet, you write down the area for segment, area of a segment, and we substitute 1 over 2 multiplied by 12 squared. Now our angle in radians is 7 over 4 pi. So if you get your angle there as 7 over 4 pi, so you will have 1 over 2 multiplied by your 12 squared, which is your radius. Then you also multiply it by the angle there, which is 7 over 4 pi. That is your angle in radians. So now we are going to get the area as 126 pi, or we can write it in decimal as 395,84 centimeter squared. So that's how you will be determining the 84 centimeter squared. So that's how you will be determining the area of your major sector. So now, moving forward, we're looking at the activity 1, number 3, where we have to determine the area of the shaded part. In this case, you can see that the shaded part is that blue part there. And that shaded part, we know that we call it a segment. We call it a segment. So now, in determining the area of a segment, remember we need two things there. We need one, the area of a sector, and we also need the area of triangle ABC. Correct? So now, the first thing that we know all the time is to convert our angle into radians. And how do you convert degrees to radians? You multiply by pi over 180. So if you have 120 degrees, you multiply it by pi over 180. 120 multiplied by pi over 180. So in radians, you will have 2 over 3 pi. In radians, you will have 2 over 3 pi. So now, remember, we're saying the shaded part there, we call it a segment. We call it a segment. And we spoke that for you to get the area of a segment, you must have two things. You must have area of a sector minus area of a triangle. Correct. So now, what is the area of the sector? The area of a sector is 1 over 2 multiplied by r squared multiplied by theta. That is your area of a sector. Minus the area of now a triangle is what? Is 1 over 2 multiplied by, we can say A multiplied by B multiplied by the sine of theta. Remember, AB in this case of the triangle, it's your R. Correct? It's your R. Remember, the area of a triangle is half of the two sides with the included angle there. So now it's the same as that. So A and B, we can represent it by what? By R, because it's a radius. Remember, when I'm saying AB, I mean in this form. The angle at the side opposite B is small b, and the side opposite A is a small a. Hence, I said A and B, correct, multiplied by sine of the included angle. So in this case now, when we move forward, we want to calculate the area. We know that our R is 24 squared and our angle is 2 over 3 pi. Minus, now the area is 1 over 2 into, obviously is going to be 24 and 24, which is 24 squared as well. But now we multiply by the sine of what? Remember, in terms of the triangle, when you determining your angle there, your sine, it will be in your degrees as you are calculating it. It will be in your degrees because there are two different things there. There is an area of a segment. We say the angle, it must be in radians. Correct. And when we determine the area of the triangle, your angle will be in degrees. So those are the two things that normally will confuse our learners. Those are the two things that normally will confuse our learners. Because if ever you were to use your degrees, your sine in radians, correct, and your calculator is in degrees, it will give you a different answer. So now we are going to use it in a different way. So we're going to have 1 over 2 of what? Of 24 squared multiplied by 2 over 3 pi. That one is the area of a sector. Remember, area of a sector must always be in, the angle must always be in radians. So the angle, the area there is going to be 603,19. Correct? That is the area of a sector. Now you will subtract the area of a triangle, which is going to be 1 over 2. Then you will have 24 multiplied by 24, because those are your radius, and then you will have your sine of 120 degrees, which is your included angle. Then from there you will have 249,42. Correct? Then the minute you say 603,19 minus 249,42, then your area of your segment, the area of the segment, it will be 353,77. So that's how you will be determining the area of your segment. So the trick here is between the angles. When you determine using the radians, when you determine the angle using your radians of a sector and degrees of of a triangle. So those are the two different things that most of our learners will make mistakes of when they are determining the area of a segment. Okay, I hope it was clear, that one. Then we go to our second part of the lesson, where we will be dealing with the relationship between the diameter, the height of the segment, and the length of a chord. Correct. So now in this topic, you will be given the diagram like the one that I am giving you. Remember, drawing of sketches, they will differ, but the interpretation, it will be the same. So now, we have to understand in terms of this type of a topic, when we are talking about the diameter, which is the distance of CD, it's a diameter, and AB, it's a length of chord, and we also have what we call CE. CE is the height of the segment, and then we also have DE, which is the height of the major segment. Remember, we have also the minor and the major height of the segment. Correct. And then if you add the two height of the segments with the major and the minor, they will give you a diameter. Okay. So now, in terms of the formula sheet, in the formula sheet, this type of descriptions that I was giving you now, they give you in terms of a formula. You go to your formula sheet, you will see a formula that says 4h squared minus 4dh plus x squared is equal to 0. Then that is the formula of the relationship between the diameter, the height of the segment, and the arc length. I mean the length of a chord, the length of a chord. So now, the diameter is represented by small letter d, and the length of chord is represented by x, and your height is represented by h. And the nice part about this is that in terms of this formula, in the formula sheet, the way I am describing it here is the way it's described in the formula sheet. They will tell you that D represents the diameter, X represents the chord, and H represents the height of the segment. Correct. So now that's what you will be given in the formula sheet. So now, let's look at activity 2. In activity 2, the question says you must consider the diagram alongside. We have our diagram there. Then the question says we must determine the length of a diameter AB. We must determine the length of the diameter AB. So now, remember, if you are you are having this type of a question, the first thing that you will do, you will quickly run to your formula sheet. Run to your formula sheet, and then you rewrite that formula in full. So one of the mistakes that learners are doing most of the time is to omit equal to 0. We see that when learners are writing, they will look at the formula in the formula sheet, but they will write it as an incomplete, of which it will be wrong. The formula, as long as it's there in the formula sheet, you must write it in full. 4h squared minus 4dh plus x squared is equal to 0. Then now you go and identify what is given in your diagram. Remember, we are looking for h, we are looking for d, and we are looking for x. All those things, we need to identify them on our sketch. So remember, we're saying h is the height of the segment. We have the smaller or minor height of the segment there, correct, which is 4. So you will say h is your 4. Your diameter, because we don't know it, it will be question mark there because that's what we are looking for. Then now, the x represents the length of a chord. So in this case, you can see that your chord is QP, the length of that QP there. So QP, it says, is 8 plus 8, which is going to be what? 16. So the length of your chord is 16. So in this case now, we are going to now determine the length of a diameter. So what you do, you're going to substitute. As you substitute, you see our h is 4, and we don't know what is our d, but our h is 4. Plus our x is 16 squared, it's equal to 0. Another mistake that learners are doing most of the time is to also omit the squared, especially on the x squared. They omit the squared when they are writing this, or when they are substituting inside in this formula. That's the mistakes that learners do. So learners must avoid making that mistake. So in this case, you will get 1 mark for your formula and 1 mark for your correct substitution. Then from there, you will have to make your D the subject of the formula. What do we do now? We're saying 4 into 4 squared. What do we get? We get 64 here. Then from there, if you say 4 multiplied by 4d multiplied, negative 4d multiplied by 4, you're going to have negative 16d. Then plus, if you say 16 squared, you are going to get 256. It's equal to 0. So now we have the like terms. You are having the constant of 64 and 256. We're going to add them together and we transpose them to the right hand side. So we're going to have negative 16d, it's equal to, if you say 256 multiplied by, plus 16, you are going to get 272. So you transpose 272 to the right hand side. It will be negative. Then because we are looking for d, you will eliminate your 16, or we're saying you get rid of your 16 by dividing both sides by 16. So negative 16 there, that's what we're getting rid of. So in this case, therefore, our diameter is going to be 17. Our diameter is going to be 17. It means 17 is our diameter. So that's how you calculate the diameter using that formula of the relationship between the diameter, length of the segment, and the height of the segment and the length of chord. Okay? So moving forward now, we have another sketch here, and then activity 2 continues. Number 2, they say consider the diagram alongside, correct? And we must determine the height of the segment LR. So now we're looking at our diagram there. You can see that you are given the length of LR. Not LR. You are given the length of LR, that's what we are looking for. The length of LR, that's what we are looking for. But there are certain dimensions that are given there. You can see that your PR is given as 2, correct? And if your PR is given as 2, then you will know that when we were dealing with Euclidean geometry, this is the integration of topics now, correct? It's given that BR is perpendicular to, or BL is perpendicular to PT. So if BL is perpendicular to PT, we know the theorem of saying the line drawn from the center of a circle perpendicular to the chord bisect the chord. So now, your PR and your RT, they are equal in length. Your PR and RT, they are equal in length because of the line drawn from the center of a circle perpendicular to the chord, it bisects the chord. So our chord, it will be bisected by 2 and 2. It means the total length of chord is 4. Correct? So now, the few things that we have to do here is to get our H, our D, and our X. In this case, the formula the question says we must determine the height, of which H is unknown. Our H is unknown. Then we're looking for the diameter. The diameter, you can see that you are given the radius. From O to B, they tell you that the radius of that circle is 8. So if the radius is 8, for you to get the diameter, you will multiply by 2, then you get what? You get 16. It means in this case, our diameter is 16. Remember, radius is 8 for you to get the diameter because the formula requires a diameter, not a radius. So you will take that 8, multiply it by 2, then you are going to get your diameter. And in terms of the length of a chord, we are going to have 4 because we will be adding 2 plus 2. And I've explained how to get another part of 2 to saying that was the integration of 2 topics, which is your circle angles and angular movement, also your Euclidean geometry. That is the method or the technique that we were supposed to use there. Then from there, we are going to rewrite your formula. Let's rewrite our formula, which is 4dh plus x squared is equal to 0. Then we're dealing with substitution now. We're going to have 4h squared because we don't know what is our h. We are looking for h. So we have 4 into our diameter. We agreed that is going to be 16 plus our length of chord. Our length of chord, we are going to substitute it, is going to be 4 squared is equal to 0. Remember, I explained the importance of substitution and the equation and the formula that is given there, that it must be written in full. So in this case, you will realize that you have 4h squared, and if you say negative 4 multiplied by 16, you are going to get negative 64h plus. If you say 4 squared, you are going to get 16, not 12. 4 squared is 16. 4 squared is going to be 16, which is 4 times 4. So for you to determine the length of a segment, you will arrive at this step here. Then when you arrive at this step, you realize that actually this equation in terms of h is the quadratic equation. It's your quadratic equation because you are having h squared, h, and a constant. Correct. That is your quadratic equation. And when you have a quadratic equation, it means we will have to identify what is our A, what is our B, and what is our C, so that we can use what we call your quadratic formula. So in quadratic formula, in terms of h, we know that your quadratic formula is this. Now we are doing it in terms of h. We can't put x because now we are looking for h. We'll put it in terms of h. We'll put it in terms of h. So now, substituting in our quadratic formula, we know that we are having minus b plus minus the square root of b squared minus 4ac all over 2a. That's what we will be looking for there. Then we will know that our h is equal to, or our h is equal to. So in this case now, what happens? We need to substitute. What is our a, what is our b, and what is our c? The quadratic formula, it says negative b, which is going to be negative 64. Our b, remember, is negative 64. And then our a is 4. Our a is 4, and our c is 16. And our a is also 4. So we are going to get 2 height of the segment there. So now we are punching our quadratic formula there as negative 64 plus into negative 64 squared minus 4 into 4 and 16. You divide it by 2 into 4. Correct? So the first part, it will give us 15,75. You will get 15,75. And then when you change it to negative, if we put negative there, then we are going to get 0,25. Correct. So those are the 2 heights that you will be given there. So from now, in this case, we know that the smaller one is the one of LR. So in this case, it means LR is equal to 0,25 centimeter. That's how you get your LR, because you are having 2 heights there. The one from R to B is your 15,75. And then the one from R to L, that is going to be 0,25 centimeter. If you add the 2 height of the segment, the minor and the major, they are going to give you 16. And 16 is your diameter of that circle there. So remember, the first one, we were calculating the diameter. The second one, we are now calculating the length of, the height of the segment. So you need to always be ready to have this type of questions. Sometimes they will ask you to determine the diameter. Sometimes they will ask you to determine the height of the segment. So you need to do all these methods. So the third one now, activity 2 still continues. Now we have the statement there in the diagram alongside AP is equal to 2 centimeter and BP is equal to 4 centimeter. Correct? Then now they are saying you must write down the length of AB. And if you can check, the length of AB is your diameter. So that was the simplest one. We know that AB, it will be 2 plus 4, which is 6 centimeter. It means now, in this case, our diameter is 6 centimeter. Correct. So now, the question number 2, it says you must determine the length of chord CD. So that's what we are looking for now. The length of chord CD. Correct. Remember, I've explained that in this case, we need to identify your H, your D, and your X. Your height of the segment, diameter, and the length of chord. So in this case, diameter is AB, which is what? 6. It was given there. Then the height of the 6 is the diameter. The height of the segment, that's what I wanted to start with. The height of the segment is 2. Minor segment is 2. So we have diameter, which is 6. And we don't know what is our CD, which is the length of chord. So now, in this case, what do we do here? Remember, we must determine the length of chord. So we go to our formula. 4h squared minus 4 dh plus x squared is equal to 0. So from our previous slide there, we know that our h is 2 and our d is 6. So when we substitute, where there is h, we substitute 2 minus 4. And where there is d, we substitute 6. And where there is h, we substitute 2 plus x squared is equal to 0. Then now, you will have to make x the subject of the formula. So, if you say 2 squared is 4, multiply by 4, you get 16. Correct? And if you say negative 4 multiplied by 6, you will get 24, and 24 multiplied by 2, you will get negative 48, if I'm not mistaken. We'll double check that. So negative 4 multiplied by 6 and 2, you get negative 48, of which I'm correct. So you got negative 48 plus x squared is equal to 0. So in this case, you'll add the 2. You will say 16 minus 48. You are going to get negative 32 plus x squared is equal to 0. We want x squared, we transpose that. X squared is equal to 32. So now, to get rid of squared, we'll introduce the square root. Therefore, your x is going to be, if you go to your calculator and say the square root of 32, you will have 4 root of 2. And that is equivalent to 5,66. So that is your CD. That is your CD. It means the length of CD is 5,66. That's how you get your length of CD, which is the length of chord. So that's what you will be required to calculate in your test and exam. Remember, you must know all the method, and you must know how to manipulate the formulas in terms of looking for the diameter, looking for the height of the segment, and looking for the length of chord. Those are the 3 things that you need to be able to calculate when we are dealing with the relationship between the diameter, height of the segment, and the length of a chord. Okay. When we move forward, we have an activity 3 there. And in activity 3, these are exam types of questions. So you can see that there is a statement and there is a diagram where you have to analyze from it. So in this picture, they say, the picture and the diagram below shows the area covered by a beam of a light cast by a torch lying on the floor, correct? Then the light beam covers the distance of 1.8 meters, and the beam angle is alpha, correct? The floor area covered by the beam of light is 2.5 meters squared. 2.5 meters squared. Correct. That is the floor covered by the beam of a light. So now, the question says we must show that alpha in degrees, it's an acute angle, and you must justify your answer. So you see, when they're saying you must justify your answer, it means you must put a conclusion on your answer in weights. In weights. Correct. So now, what is going to happen here? We are going to, firstly, we know what is our area. Remember they said area covered by the floor, area of a beam light. That is the area, ne? Covered by the beam is 2,5 meter squared. Right? Then they're saying the distance there of the light is 1.8, like is illustrated here. We have 1.8. It also means that we have 1.8 that side. Correct? And then the area they're saying is 2,5 meters squared. The shape that we are given here, we can see that we are given the shape of a what? Of a sector. It means the area that is given here is the area of a sector. Correct. So now we are going to use the area of a sector to determine our angle. And area of a sector is what? Is area, it's equal to 1/2 multiplied by r squared and multiply it by alpha. Your theta. Sorry. In this case, it's a theta. That's how you will be seeing it from the formula sheet. So as you substitute, remember your area they're saying is 2,5. So you're going to have 2,5 in terms of your area. And then you will have 1/2 and your r is 1.8 squared. That is your radius, correct? And then multiply it by your alpha. Remember, the angle there is given as alpha. So how then are we going to determine our angle there? And remember, when you determine the angle, they said you must determine your angle in degrees. Correct. So now we are going to divide both sides by 1/2 multiplied by 1,8 squared. So also this side, we divide by 1/2 multiplied by 1,8 squared. So what will happen here is that 1/2 multiplied by 1,8 and 1/2 multiplied by 1,8 squared, they will cancel out. Then you will have your alpha. Then on the left hand side, you will go through your punch in your calculator. Then you have 1/2 multiplied by 1,8 squared. So with that, you will get 1,54 radians. 1,54 radians. Correct. Or we can write it in fraction as what? As 125 all over 81. But the answer is in radians. But the question says we must determine we must show that theta in degrees is an acute angle. And remember, an acute angle is an angle that is less than 90 degrees. So what will happen here? We are going to convert our alpha. We are going to convert our alpha in degrees. Then we're going to have 125 all over 81. That's what we got there. 125 all over 81. Then when we want to convert it to the degrees, then we're going to multiply by 180 degrees divided by pi. That's where now you convert from radians to the degrees. Therefore, your alpha is going to be, if you say 125 divided by 180 multiply by 180 divided by pi, you will find that your angle there is 88,42 degrees. Your angle there in degrees is going to be 88,42 degrees. And remember, the question says you must show that it's an acute angle and you must justify your answer. So you will say now that 88,42 Therefore, 88.42 degrees is less than 90 degrees. It's less than 90 degrees. Then we know that it's an acute angle. That's how you will justify your answer to show that it's an acute angle. Correct. So now, moving forward, we have activity number 4. So this type of questions, there are exam types of questions, and they ask them in different ways. But they asked the same thing in different concepts. You can see that now, the previous one we were talking about the torch. Now we are going to be talking about the top of a can. But the procedure is the same. So let's go through our activity 4. Number 1, they're saying the picture below and the diagram, the picture and the diagram below shows the circular top of a can, correct, with center O, as is illustrated there. Then the radius OB is equal to 26 millimeters, correct? And AOB, yes, it's 26, and AB is a chord, and the height MC of a smaller segment is 20 millimeters. That's what is given there, correct? And you can see your picture and your illustration of the diagram. Then the question there will say you must determine the length of chord AB. So now we are required to determine the length of what? Of chord AB. Like I said, that this type of questions, they are exam type of questions. Then now in this case, they are giving you a scenario. It means you must read your scenario or statement and look at the diagrams that are given and analyze from the diagram. So remember, in this question, what you need to know this formula. And this formula is in your formula sheet. You must firstly identify height of a segment, the diameter, and x, which is the length of a chord. In this case, we are given OB. OB is a radius, good people. And for us to get, a diameter, we know what is it that we must do with our radius. Radius is 26. You multiply it by 2, you will get 52. So 26 multiplied by 2 is going to be 52. It means 52 now is your diameter. Correct. And you were given the height of the smaller segment, which is 20. And now we know that x, that represents the length of chord, is not given. We have to look for it. And we have done the example like that one. So now, how do we now go to the solutions now? The first thing that we need to do is to rewrite our formula in full and correctly so. Then we have to now substitute. We know our h is 20, 4, and our d we know that is 52, and our h is 20 plus x squared is equal to 0. We can double check them. It's correct that h is 20 and d is 52. So we need to make x the subject of the formula. So what will happen here? You will say 4 into 20 squared. Then you are going to get 1,600. So if you say minus 4 multiplied by 52 and you also multiply it by 20, you're going to get negative 4,160 plus x squared is equal to 0. So we have to make x the subject of the formula. What will happen here? We'll just add the 2, go 1.6, which is 1,600 minus 4,160. Then if I now take the addition of that thing to the right-hand side, I will get 2,560. X squared is equal to 2,560. Then what will happen there? You will introduce the square root to get your x. So if you introduce the square root, then your x will be the square root of 2,560, which is going to give you 10. Let's write it nicely there. It's going to give you 10. 10,60. When you round it to 2 decimal place, you're going to get 10,60, and we're talking about millimeters there. We're talking about millimeters. So this is how you are going to get your length of a chord. Correct? Then now, we're moving forward to activity 5. So now, looking at activity 5, always you will be given a statement there or a bit of a scenario. So now, the scenario or the statement given, it says the diagram below. The diagram below models a sector of a circular farm. We have a sector of a circular farm. Correct? Then the shaded area must be covered with a net. The shaded area must be covered with a net. And now they are saying PQ is 50 meter. PQ is 50 meter, and OR, yeah, it's supposed to be QR, not OR. It's supposed to be QR. So your QR there is 35 centimeter. It was QR, not OR. Then QR is 35 meter. Correct? Then the central angle of a sector is 2/9 pi radians. So now the angle there of a sector is given in radians, the correct way of how we must write it. Then now, the question says we must determine the shaded area, we must determine whether the shaded area can be covered by 1,500 square meter of netting. Correct? So now you can see what is it that we need to do. We need to calculate the area of this shaded part and see if ever it can be covered by what? It can be covered by a 1,500 square meter of netting. You see the word whether, determine whether. It means also your answer, it must have a conclusion. It means at your answer, you must add a conclusion. Remember, when we're saying whether, it can be yes or not. Correct. So now, how are we going to deal with this one? So we have two sectors here. For us to get the area of that shaded part, we must firstly get the area of a smaller sector, and we must also get the area of a bigger sector. Those are the two things that we'll have to calculate. Then we're going to say the area of a bigger sector minus the area of a smaller sector. Then we are going to get the shaded part. So the first thing that we're going to do here, we're going to say area of a smaller sector, which is going to be 1 over 2. Then we can see that its radius there is 50. And then you 50 squared, then you multiply it by 2 over 9, not 9 over 2. It's going to be multiplied by 2 over 9 pi. 2 over 9 pi. Then there you will have 1 over 2 into 50 squared. Then is 2 over 9 pi. That's what you will punch in your calculator. Then you will have an answer of 2,500 over 9 pi. Correct? 2,500 over 9 pi. Or you can simply write it as 8, not 8, is 827. Is 872, 66. 872,66. Correct. Then now we will have to come and calculate the area of the bigger sector. Area of a bigger sector is 1 over 2 into, now you see here, we're going to add the length from P to R. We're going to add that length from P to R. So if 50 plus 35 is 85. So here the radius of the bigger sector is 85 squared, but the angle stays the same. The angle stays the same. So now, if you say 1 over 2 multiplied by 85 squared, correct, into your 2 over 9 pi, the angle there. Then here you're going to have 7,225 all over 9 pi. And that one, it will be equivalent to 2,522,00. Right? So now, for you to calculate now area that is shaded, the one that is shaded, then it means you are going to do what? You are going to take the area of the bigger one. So we start with the bigger one. We start with the bigger one. We're going to take the area of the bigger sector, which is 7,225 all over 9 pi. Then you subtract it by what? By 2,500 over 9 pi. I'm writing it in this form because it will be more accurate. We are not going to be rounding off so many times. So now, when we write that one, we're going to say 7,225 all over 9 pi minus 2,500 all over 9 pi. Correct? Then your answer there, it will be your 525 pi, which is equivalent to 1,649,34. Correct. So that's what you will be getting as your answer. Right. So now, if that's what you get as your answer, remember your question was like, determine whether the shaded area covered, determine whether the shaded area can be covered by 1,500 meters squared of netting. So you can see that that area there is bigger than 1,500 meters squared. Is bigger than that. The area that is there is 1,649.34 meters squared. So the question, your conclusion, in conclusion, you will say no, and the shaded part will not or can't be covered by, cannot be covered by 1,500 meters squared of netting. That's how you will put your conclusion, because they said you must determine whether it can be. So no, it can't be covered by 1,500 square meter of netting. So that's how you will answer that particular question. And remember, it's very important to write your conclusion, because conclusions also have marks. Your conclusion have marks as well. But the idea is for you to know how to calculate those areas. Correct? Then this is the end of our lesson. Remember, with this lesson, we were dealing with the sectors and segment, and also the relationship between the diameter, the height of the segment, and the length of chord. We learn by repetition. If you go and get those previous question papers and practice more, then you will understand this topic better. Thank you.